right, cool. Good morning, everyone. My name is Baron. Just a few little logistics. People always ask if there's going to be slides posted. I see a camera there. Hi, everybody. I don't know if we're live streaming or not, but if we are, hi. So I'll post the slides. You can follow me on Twitter, et cetera, et cetera. I'll certainly tweet about it there, and I'll share with the conference organizers. So this is a little bit of a follow-up to an earlier talk that I've given about what should I monitor and how should I do it. That talk was really about, of all of the things, all of the metrics, all the stuff that you can get out of a system that you're operating, which ones should you care about? And which ones should you try to get if the system doesn't provide them for you? This one is, if you're building a system or a service, then what should you try to build into it that makes it easy to observe? And so this is kind of a follow-on to how to build systems that are highly observable, highly monitorable, rather than how to monitor systems that you didn't build. So my assumption is that you're building and operating a service. For the record, Vivid Cortex is a SaaS platform that's the first such large-scale service that I've ever built and operated, and learned a lot of lessons in doing that. Learned a lot of lessons about what to emit, what to make inspectable. So the goal is to be able to operate and monitor and observe those systems better, both in production as well as to take those production insights, things that we learn about systems as we're operating them in production, feed them back into the development cycle so that we're developing systems that are easier to operate, that are easier to troubleshoot in production. Okay? So what we really want is observability, and if you haven't heard this term, it's starting to become sort of a fad. People are using it in various ways. There is a formal meaning of it, the hell with that. It's like, mathematical. The official Wikipedia page says something about, observability is the mathematical dual of controllability in control theory. I don't think anybody really cares about and understands, except for probably people who have spent academic careers focusing on what the mathematical dual of controllability is. But for us, I think a really simple definition that suffices is the ability to look at a system from the outside and understand what the heck it's doing on the inside. And it just makes sense. If you can't see what something is doing from the outside and understand its internal state, you're not going to have a good time figuring out what are the problems going on, how can we safely operate this system. And this happens in the time dimension as well. So we want to be able to look at a system right now, understand everything that's going on right now, as well as to be able to see where have we been in the past, how has this system behaved in the past, and ideally, in some circumstances, we'd like to be able to forecast that into the future or understand under hypothetical situations how will this system behave. Okay, so this is really the kinds of things that I'm going to be talking about today, instrumenting for achieving these kinds of goals. So then the question is, what should I observe about my system? You can probably think about any system or service that you have built. You can probably think about an almost unbounded number of kinds of things that you might be able to know or might be curious about or it might be fun to know about that system. And in that very large problem space, how can you narrow that down to some things that are practical and useful and doable, frankly? So, with so much to measure, that's my goal here today, is to try and help boil that down to some simple things that are relatively universal and provide extremely high value, okay? So my first tenet, which, I didn't introduce myself very much, but I have a long history of solving hard performance problems. I'm basically a performance-minded guy. And the way I've solved all of those performance problems, even the quote-unquote impossible ones, was by focusing on the work that the system is there to do. All of your systems and services have a job, and if you focus on that job, that will lead you to any problems. So that's of primary importance. And it's the same for instrumenting. It's much more important to be able to observe and instrument that work than it is necessarily the systems themselves. Now, you do need to be able to observe the systems and how they respond to the workload in order to understand that complex interplay, the dynamic of how a system behaves under load, those kinds of things. But the first importance is the workload. And I actually stole this diagram from a software engineering principle, which is about a different thing, but it applies equally well here. There's a sweet spot. You can instrument everything and get tons and tons and tons of facts and metrics and data out of your systems, or you can be really succinct and just get the things that matter the most. Okay? Don't repeat yourself on that axis. And on the other axis, a lot of things can be very opaque, be very surprising. Their meaning can be munged. You can probably think of a lot of your favorite, like IOStat. A lot of the things that you'll get from the output of IOStat are heavily processed by lots and lots of math, dividing things by other things and subtracting and all that kind of stuff. And by the time you get the digested outputs out, it's very difficult to understand what that actually means. You have to look at the source code of IOStat, and then you have to go look at the kernel source code to understand what the output of IOStat means. So you can have things that can be really surprising and obtuse, and you can have things that are absolutely self-explanatory. So our sweet spot is to get succinct, really explicit kinds of observability metrics out of our systems. You don't have to invent this for the first time. There are people who have given sort of like quick start guides, blueprints of various ways that you can do this. Brendan Gregg is one of my favorite observability and performance engineers in the whole world. His writing and his speaking is all well worth paying attention to. Follow his blog, follow him on Twitter. He has this performance debugging methods. Basically, if you don't know what else to do, or if you're approaching a system for the first time, a great way to get oriented with it is the use method. Utilization, saturation, and errors. So for every component in the system, go look at those and you'll learn things. This is like a novice's approach to something. There are better ways, and he says so himself, but this is a great way to just get started. So as a blueprint, if you wanted to think about what do I want to instrument about my systems and how, one of the things you could do is you could, for every component in your system, you could instrument utilization, saturation, and errors, right? So that's kind of like, pre-baked, ready for you to use. Tom Wilkie had a response to that called the RED method, which is actually focused, instead of on components and their utilization, saturation, and errors, it's focused on requests of a service. And I'll come back to that theme a little bit later. But it's about the rate of requests, their errors, and their duration, which are all really important things to measure about individual requests in a system. And then there's the SRE book, which has these 4 golden signals. Those, I think, can be a little bit difficult to interpret. Like, what exactly does saturation mean? How is that different from traffic? The book does a fairly decent job, I think, of digging into those kinds of things. But my point is that you start to feel like you're given a little bit of conflicting advice. Like, maybe some of these things overlap. Some of them are in a little bit different domain and are catching some things that the others don't, or maybe some things are a little bit redundant and it's difficult to tell the difference between them. So although these are helpful and you don't have to invent things from scratch, it still doesn't feel like it's sort of complete and coherent, right? There's also some laws, some equations. All 3 of these things, Little's law, the universal scalability law, and queuing theory have formal definitions as math. And if you look at the inputs and outputs of these things, there's a couple of things you'll see coming up in common. For example, throughput, concurrency, latency. These are concepts that we're already kind of familiar from the previous slide. And these are all things with a very clear, crisp definition, right? So, and I've written some books about a couple of these things that might help if you want to get an introduction to those, but not necessary for the purposes of this talk. It's just like, what's most important is just to know that there are these specific concepts that each of these deals with. And it feels a little overlapping with the previous slide. So how do we kind of bring all this together? There's a concept that I've been sort of shaping and talking about and getting ready to probably write about a little bit more, that I've been calling the Zen of Performance, which is trying to unify this around some shared concepts that can help disambiguate and make these things make a little bit more sense. And the key concept is, how do we define performance? Some people insist that performance is what you measure in a benchmark, which is usually throughput under as much load as you can throw at a system. That's kind of the universal standard benchmark, right? If you think about it. Others insist that performance is latency and nothing else. Damn it, anybody who says that performance is anything other than request latency is out of their mind. And I think it's both. I think depending on whether you're inside the boundaries of a system or outside the boundaries of the system, you will see different things. And the key is to recognize that these things meet at that boundary of the system. The external view of the user, all they know about, they don't know about things usually concurrency and stuff like that. I sent a request to your service. I waited for a while. That's it. The only thing I know is the latency. or if I got an error back. Inside, we get to see things like CPU and memory and all of these other sorts, we get to look at the utilization, saturation errors, things like that inside. So what we're really looking at is just two views of a system, and they actually meet, and they make sense where they meet. So it's both of them simultaneously. Okay? So that kind of, for me, has been very successful in resolving a lot of the confusion around this, because, for example, the classic cases where somebody says, system is down, I'm just waiting for it to load, and then the system administrator goes and says, it looks fine, I think it's up. How do we reconcile those two different perspectives of something? This is how, right? This is how. So we need to look at all aspects of the system. And then when you are responsible for owning, operating, building, and maintaining that system, the key thing is to take that holistic worldview of what performance, availability means, and then build instrumentation around those things so that when you are operating a system in production, you will be able to successfully answer all of these different types of questions and not just some of them. So what are the metrics that matter? It's basically, if you just take the union of all of those things that I mentioned before, those are all important metrics. Utilization, saturation, errors, latency, concurrency, throughput. Those are both the things that measure the requests, the units of work that your service is there to do, as well as how the components, the resources that are there to do the work are behaving under that workload. So I'll dig into how to expose those kinds of things a little bit later. A key thing to notice is that all of these things are time related. They're either snapshot, instant in time, what's happening right now, or they're over durations of time. And to keep the dimensions clean really helps a lot as you start to build this instrumentation into your systems. If you don't provide this data, then you're going to have a rough time. So I've sort of covered a lot of what's on this slide, so I'll skip past it. But I did want to mention that you don't have to necessarily build all of this stuff into your system. You can wrap components in that provide it for you, or you can build on top of a system that already provides this observability natively. For example, dtrace, extended Berkeley packet filters. Just by building on a well-instrumented operating system, you get great introspection into the things that are running in that operating system. If you wrap in a metrics library, or I'll talk a little bit later about a framework that we built for our Golang APIs at Vivid Cortex, you suddenly get a lot of stuff for free. If you don't have those things, then you start having to litter and annotate your source code with instrumentation, and that can be a little bit, catch as catch can, so you might miss something you really, really want, and then you have to go through a build and deploy cycle to get it. And it detracts from the quality and readability of the source code itself. So I prefer building into highly observable systems when possible. So, when we think about a service and observability, I said observability is being able to look at something from the outside and understand what it's doing on the inside. Components have to be broken down internally because there's almost always subcomponents, subsystems, and if you don't have clearly defined boundaries between them, you'll have a really, really hard time understanding, a request went in there, it didn't come out yet, what next, right? So defining the architecture of your system really clearly, breaking it down into things that have clear boundaries, and then instrumenting particularly, as we'll see, when things enter and when they exit from a component or a subcomponent is really helpful. And if you can draw an architecture diagram or even a marketecture diagram of your system, I'll refer back to Brendan Gregg again. He's done a lot of great diagrams explaining, for example, how the Linux I/O stack works. It's really complicated. But by diagramming it, he is able to then understand, and he's able to point other people to, here's what's going on with an I/O request in Linux, and now we can make these things make sense. So if you do that for your own systems, of course, we know this is good practice to build systems cleanly and well anyway. But in order to observe them, it makes it even better to do that. So, and then the last thing I wanted to mention is, the richer instrumentation you can get on requests, those units of work flowing through your service, the better. However, the metrics on the components, like the resources, for example, CPU utilization, there's definitely a point of diminishing returns. And the basics are usually there already, and trying to instrument absolutely everything generally doesn't help a lot. So I'll give you an example of a system that has lots and lots of instrumentation on everything other than requests is MySQL, the database server. It has 350 metrics in this command called show status. And a lot of those are just things that a developer was working on a feature and they were like, I don't know, I'll just emit a status counter for this feature I'm working on. And now we went from 350 to 351 or 355, and it didn't really add any value for the user. It's just sort of like, I don't know if anybody is going to need this metric, but I'll put it there. That can actually be more of a negative than a positive. Because if you are trying to troubleshoot a system in production and you've got tons and tons of vanity and irrelevant metrics, it greatly increases your cognitive load when you're trying to narrow the search space and figure out why is this thing stuck or not behaving as I expect. So there's a concept that's in every mature system. Every mature service eventually builds in a process list. It's inevitable. And I'll get a little bit later to how you can build a process list into your own service, and it can be really easy. But you'll see this in everything, in the operating system, in databases, in web servers, anything that's handling requests and has workers, you'll generally have a process list and you'll be able to observe at least some of what they do, and this can be a great foundation for building off of. There's these attributes that you'll see pretty much universally across process lists. There's the worker, like a thread in Apache or a connection to a database server. You'll be able to see whether it's idle or whether it's handling a request. You'll be able to see something about the nature of that request. What characterizes it, like the SQL text or the command line and the arguments or the verb and the URL arguments. You'll be able to see kind of states if a system is in a little bit more mature state of development. They'll typically have a state like parsing and executing and cleaning up and things like that. Ideally, you'd like to be able to see timings. You'll almost always be able to see a time since begin, but if you can see historical timings about the states, how long things have been in those states. It can get richer and richer, but there's a couple of basics that are really pretty universal, and you don't have to, this is, again, something you don't have to invent from scratch. So the example that I've mentioned previously is our Golang HTTP APIs. They're built on top of the standard net HTTP package in Go. And we just wrapped in a little process list package. It's open source, called PM on our GitHub repositories. It's not very much code. It tracks the existence of a request. It allows you to kill it. It has an API for setting the state of that request as you kind of working through an HTTP request. You can go, I'm authorizing against my database. So it's kind of the HTTP stuff is an underlying stuff, and then there's the service that we're building on top of that. Authorization, sharding out into parallel workers, cleaning up, doing whatever. And those are things that we can kind of instrument into our process list, and all of this is tracked and timed. There's an HTTP API to that. A little Angular JS web app allows us to see our entire fleet, every request in flight, anywhere in our fleet, kill them, see how long they've been running, what state they're in, all of those kinds of things. So with that framework, not too much code, and really not much burden to instrument if you're building a service using this framework. We get a lot of observability into our services internally. So that's great for like what's going on inside of our systems right now, every request in flight, anywhere. But what about the historical stuff? So a lot of monitoring systems are basically a historical set of snapshots of instant-in-time things expressed as metrics, usually expressed as metrics, Datadog, Graphite, et cetera, usually the underlying thing there is a metric. And one of the foundations of good historical observability is to just take that current observability and take snapshots of it. In fact, if you can't observe it now, chances are you're not going to have any way to get any historical observability and metrics about it at all anyway. So focusing on being able to see complete state of what's going on inside your systems right now is the foundation for history as well. And so again, for requests, tracking the transitions and the timings and the state changes and all of those kinds of things in the moment allows you to have, depending on your systems that you're using to record this information, your monitoring, your logging, analytics systems, allows you to have that really rich historical view of what was going on in a moment in time in the past. And so I like to do three things with these. I like to emit events, facts, log is the sort of the least common denominator here, writing something to a log. But what you're writing in a log file message is really a fact. It's an event at a moment in time. This thing changed from this state to another. This thing started, this thing completed, that kind of stuff. You can aggregate those things into metrics. Metrics have good properties that I'll talk about in a minute. And you can also take samples of things, tie those things together, and you end up with traces. So these are kind of three really core concepts in good historical observability of systems. And then for the components, if you've got, for example, a buffer built into your system where, requests can go, a queuing mechanism or something like that, getting the utilization, the backlog, those kinds of things from those kinds of components, and then emitting those as metrics usually as well. So all the types of metrics we talked about before. So how do these logs, metrics, and traces, how are they related and how are they different? I don't think that this diagram is completely perfect, I think, but it's a start, and the blog post behind it, this guy named Peter Bourgon wrote, it was from a distributed tracing conference, and I think it arose out of some conversations. I wasn't there for the conference, but I found it really helpful to kind of boil things down into at least a smaller set of stuff that we can talk about. So we have more common concepts, and we're talking more of a shared language. So I think this is really good blog post to read. But the key point is that there's a couple of properties around these things, like metrics are aggregatable, they're downsamplable, they can become very small, the volume is generally low. That's not true for Vivid Cortex. We have a really high volume of metrics, but in most systems, the metrics volume is rather low. Tracing is somewhere in the middle because it's typically sampled, and then logging and events is really, really high volume because you're typically the thing that happens or emitting events and facts about everything that happens. And then there's this sweet spot in the middle where you get some stuff that can kind of have the common properties of all three. Distributed, not distributed, but request-scoped aggregatable events. Most monitoring systems are not built for that kind of data as an input. They're more built for metrics as an input or log lines as an input. But I think this kind of leads the way towards potentially seeing some better things in the future. As for logging, if you've ever watched the log of a service running when you're trying to figure out what's going on with it, typically what you discover is that most of the log lines are zero value. Again, they're just noise and distraction, and they don't help you to understand what the system is doing. As a solution to that, one of the best observations that I've seen is that most logging comes through log libraries that encourage a profusion of different kinds of things, like log4j. You've got all of these different log levels. And I think Dave Cheney's blog post that I've linked here is a really good explanation about why simpler is better. You really only need things that an operator could use to understand the state of a system they're trying to troubleshoot, or that a user would care about when they're using your service. And I think boiling things down to a little bit more of the simplicity there can help to avoid some of the noise. I really don't like the way a lot of tracing and sampling is currently done, and there's a lot of people writing about how you should sample, and they bring fancy words in like horizontal sampling or vertical sampling or things like that. What they're really saying is, hey, it's okay to throw away a whole lot of data about your system and your requests and your users' behavior and just ignore basically everything. I really think it's much better not to ignore anything. I like the Dynatrace philosophy. Everything matters, get full visibility. It's extremely costly to do that in a lot of cases. Like even just putting these logs into S3, can be really, really expensive, much less the systems that you have to run on top of them. So what I favor doing is measuring everything, aggregating those things into metrics, which again are aggregatable, and those can be much, much smaller, and then keeping a sample of some of the facts so that you can get back to the original facts. Because when you've aggregated things into metrics, you can't disaggregate and get back the original data that generated those metrics. So I think the combination of those things is really, really beneficial. I've written about how we do that at Vivid Cortex. This is a free ebook. There's a little bit of math, but it's not really hard. We get really great visibility into the behavior and workload, every single request of these really high volume database servers. That's what we do. We observe database servers doing their thing. And we get the benefits of being able to look at individual requests as well as the benefits of measuring everything. So the measure everything turns into metrics, and the individual requests that we pick out in a very careful way to be representative end up getting retained in full original glory that we can inspect at any time. I'd be happy to see more systems doing it this way because it works really, really well. The last thing I wanted to talk about is the culture of observability. So observability is starting to get, again, sort of trendy and hyped, and everybody is jumping on it. Just like they sort of jumped on DevOps, buy a DevOps tool. I'm a DevOps. All of these different things that some of us were like, that's not what we were all talking about a few minutes ago. So observability is one of those things too. Observability is not a tool. However, I do think it's fair to describe a culture of observability, meaning a culture that values observable systems. And the question is, how do you get that? Like, how do you build an observability culture inside of your company? There are now, particularly in Silicon Valley, a lot of observability teams. Like it's pretty common for teams that used to call themselves the monitoring team to be shifting slightly their mindset and focusing on creating observability rather than just consuming data and turning it into monitoring. So the key here is that whatever you reward is what you'll get more of. So if you reward like measuring everything, putting it into a monitoring system, you'll certainly get that. Will you get insights out? Maybe not. You'll have lots and lots of data, maybe not a lot of understanding and knowledge. And the key thing I think is to understand that when you see companies doing something, that's an externally visible artifact of their culture. That is not the culture itself. And it can be really easy to mistake the means for the end. There's a couple of examples for where I've seen people try and transplant what they see other people doing, and it doesn't take root. Like a lot of companies have tried to ship software the way that Etsy ships software, and it doesn't really work the way that it works at Etsy because it's more than just that, right? There's something underlying. The way that Etsy ships software is an outcome of other things that are probably worth studying more than just the way that they ship software. So I like to try and reward really clear thinking, intentionality, purposefulness, doing things for good reasons, and being clear about the reasons and the requirements for those things rather than kind of a solution in search of a problem, which I assume a lot of us are engineers here, but boy, I love solutions in search of a problem. I am so guilty of having built so many of those things because I thought they were pretty cool. Empathy, really understanding what it's like to operate the service that you're building, and there's nothing like shared responsibility and being on call for helping to generate that empathy, and really, taking that feedback loop and connecting it back to from whence the software originated. Of course, attendance at DevOpsDays is awesome. And as another example, using Etsy, which, by the way, Etsy, one of my very few stickers on my laptop. Their Code as Craft blog is great. One of their original Code as Craft blog posts was about the Church of Metrics, I think it's called, or the Church of Graphs. If it moves, graph it. If it doesn't move, graph it anyway, just in case it makes a run for it. If you read that blog post again, what you'll see is that although they were talking about graphing everything that they could, including the coffee machine and things like that, what they're really trying to do, that is the way that they're trying to create an outcome, rather than, they're not graphing things for their own sake. And so I think that's, a lesson well worth learning. So just a few parting thoughts. I've written some of this into another ebook. All of these perspective images are ebooks that are available on the Vivid Cortex website. So I've written a bunch about this stuff, but just to wrap up, I think you get better results if you're really clear on things like what's the definition of performance, what does observability mean, what are the most valuable metrics that are really key performance indicators rather than throwing 350 things into show status output and that kind of thing. And go forth and make your systems observable. Thanks.